So just a quick follow-up to Paul's presentation. This topic of testing the Internet of Things, I did a presentation on something similar or related to that called Skynet is Here. You all know what Skynet is? Yeah, it's the Terminator. Yeah. So there's a recorded version of that webinar posted out on the RBCS website if you want to take a listen to it. Paul was more focused, I think, on the technological end of it. How do we test this? And I was more focused on the sociological end of it, like what are the human implications of all of this stuff happening, and can we even test it? So if you're curious about that, feel free to take a look at it. And if any of you were wondering, what is this brown stuff that I'm drinking? Yeah. Yes, I am from the United States, and yes, I do drink whiskey, but this is not whiskey, okay? And speaking of which, Paul mentioned Dodge City, which is a famous Old West town in the United States, and he talked about people carrying guns and shooting each other. Just understand, many of us Americans who have guns have never shot anybody and have no intention of shooting anybody. So, don't be afraid. Some of us are armed and harmless, okay? Most of us are armed and harmless. All right, so tools. Excuse me, something in the air here, some kind of blooming thing that's making me cough a lot. But, so tools are great, and as Paul said, we are going to need a lot of them, and that's definitely true. The need will continue, but unfortunately, tools are often very expensive. So people were asking me yesterday during my risk-based testing talk about, can test management tools support risk-based testing? I said, yeah, but what's your budget? And they said, zero. Ah, okay. So then you need to get open source tools, free tools, right? So you might think, free, that's great. Free is always in budget. I can always afford free, right? Well, yeah, but your time isn't free, right? So if you just go out and pull something down off the internet and go, this is so cool because it's free, and then you spend, 3 months trying to get it to work, and then you discover, no, it doesn't work at all. Your 3 months were not free, were they? Right? So this happens. This happens not infrequently. You can waste a lot of time if you don't choose the right tools. Okay. Now, I'm going to give you some examples of tools free tools that have been successfully used by our clients, and point out some, that this has worked and this hasn't, and so forth. Just give you some thoughts. Now, there's a bigger question here, which is, how do I go about selecting the tool? Okay. Now, I'm not going to talk about that because that's a fairly extensive process. But I am going to be doing a free webinar on that in June. So if you go to our website and you register for that webinar, it happens at 1 p.m. Central Time, which is kind of late in the evening here, I understand. If you don't have time to listen to it, or you don't feel like staying up until what would that be, 8 p.m., 9 p.m.? Something like that. You can always listen to the recorded version later. I strongly encourage you to not just go, cool, free tool, let me go download it, right? Rex said that worked at the conference, but I don't want you to do that, because some of these tools have been successfully used by my clients, and you could download them and then find out, no, my problem is different than the client that successfully used it that Rex talked about. Okay, so selection is important here. All right, so most of the time, I think, when people talk about test automation, they're talking about graphical user interface automation, right? If I say automated testing, you're thinking automated testing through the GUI, yeah? Okay, so what's out there? Well, Selenium, yeah? That's the one that we hear of most often from our clients as being successfully used, when it's used right. Okay, I've heard plenty of stories about it being used wrong. which is there's insufficient attention paid to building a proper keyword-driven architecture for the automation prior to starting to create the automated tests. And then you get the usual unmaintainable pile of garbage scripts. Okay? And a lot of times when this happens, people don't actually know it has happened. So one of the things that is very important, and this is true with any tool, but especially with these graphical user interface test automation tools, have a business case and be able to measure the return on investment. Okay? And when you measure the return on investment, what you're looking at is how much time is saved by running these automated tests compared to doing it manually. But you also have to look at what is the cost of first developing the automated tests and then maintaining them. Okay? Know what your return on investment is for this. And I've talked to clients before, they've spent a lot of money on automation, and one of the first things I'll ask them typically is, what's your return on investment? And almost always they just kind of look at me and go, uh-oh. Consultant asked me a question I should know how to answer, and I don't. Right? So we're bad that way, consultants. We are, because we know, we've seen these things happen before, so we know the questions to ask that, you know, people probably don't know the answer to. So be smart. Outsmart the consultant who comes in, and know your return on investment for your automation. Okay? So performance testing. Let's say you need to do performance testing. So I guess what we probably see most frequently in terms of free tools being used for performance testing is JMeter. That seems to be the one that's most commonly used, open source. We do see a lot of people doing, you know, what is HP calling it now? Performance Center, I think, is their current name for it. And there's the cloud-based solution, SOSTA. But, you know, that's great if you've got just money, right? But I assume that since you're here listening to me talk about free tools, you don't. So if you don't have a lot of money, then, you know, don't even bother looking at SOSTA and Performance Center, because, you know, our clients who have looked at that have always come away pretty shell-shocked by the price. Okay. We do see some people using a tool called OpenSTA. Seems to be much less common than JMeter. Now, the good thing with these performance testing options is that usually you're going to build the load generation scripts, use them, and throw them away. Just rebuild them the next time. So maintenance is less of an issue here. But what we have seen be a big issue is people doing performance testing who don't understand performance testing. Okay? We have a saying in the United States, a fool with a tool is still a fool. Okay? There is no like concentrated wisdom in those tools. It's going to like drip down your forehead and into your eyes, you know, like Jimi Hendrix at Woodstock. No? Okay. Anyway. Jimi Hendrix, you know Jimi Hendrix, right? Yeah. Jimi Hendrix, okay, good. Jimi Hendrix at Woodstock had a bandana over his head, and when he started to sweat, the bandana was dripping into his eyes, and you know what was in the sweat? Anyone? Trivia question? LSD. So he got more creative as the day went on, apparently. So anyway, you're not going to have anything, LSD, wisdom, anything like that, dripping into your eyes from using these tools, okay? And so, and the reason I'm bringing this up is that performance testing and performance optimization for systems is really complicated. There are a lot of things that you have to know about the architecture of systems and how they work and so forth. And I see this happen over and over again, that people that do not understand how systems are built, how the underlying technology works, they start doing performance testing. And then they have these results, and they think the results are meaningful. They report the results. People make decisions based on the results. The results are wrong. Okay, so do yourself a favor. If you're going to try to do some performance testing, before you download any of these tools and start doing it, educate yourself about how to do proper performance testing, understanding the technology that you're working with and so forth, because you don't want to generate a bunch of test results that, look reasonable but are totally meaningless. Now, another thing I'll mention here too is there have been some performance testing tools out there that were open source, available to everybody, and they went away. Okay? Was withdrawn from being available openly. So this is always a risk with the free tools. So any free tool that you look at, is it actually open source, or is it a tool that is a downsized version of a commercial tool? Might the downsized version of the commercial tool be withdrawn and people be forced to either upgrade or move? Something to keep in mind. All right, web services. Testing web service. How many of you doing web service type of stuff? Yeah, quite a few, right. So what we see typically here is SOAP UI used for this. This is the free tool. Now, it's really, this is one of those kind of stripped down versions of a commercial tool that's, the commercial version is offered by SmartBear. Okay. SmartBear also often offers a commercial test automation tool, graphical user interface test automation tool called Test Complete. Okay. So SOAP UI works, but it's not the world's most reliable thing. It's kind of temperamental. Okay, so you can use it and it'll work for you, but you have to be careful to save your work frequently, because you might be in the middle of doing something and then it just goes beep, and it's gone. So if you didn't save your work, then you have to create it all over again. The commercial version you would think would be better, but apparently it's not, from what I've heard from my clients. It suffers the same kind of problems. I don't know what you get out of the commercial version. I guess more features, but not more reliability. I did a web search too to see, well, beyond SOAP UI, what else is out there, and what seems to show up frequently is TestMaker and Web Inject. But I have to say that of all the clients that we've worked with around the world, nobody's using it. Any of you using either of those? TestMaker, Web Inject? Yes? No? Okay. I was hoping to see somebody say yes and I love it or something, but no. So apparently those of you who are doing this, you're all using SOAP UI, right? Yeah, okay. And it's not very reliable, is it? It works, yeah. Okay, so dynamic analysis. If you're doing performance testing, reliability testing, other types of testing where you need to, what we would say in the United States is look under the hood. You know that expression? Look under the hood. Meaning actually check, see what's going on inside the system while you're testing it. So if you need to do that, what you need is what's called a dynamic analysis tool. Now, most of the operating systems that you'll be working on will have some sort of built-in dynamic analysis capability. So if you're a Linux world, how many of you are doing Linux type of stuff? How many more Windows-based? Okay, yeah, there's really more out there for those of you who are in the Linux, Unix kind of world than the Windows world here. But if you're in Linux, you have top and some other options that are built into Linux. At Windows, you have perfmon. Now, let's suppose that you are looking for a memory leak. All right, you know what a memory leak is? Yeah. C or C++ or some similar language that allows you to allocate memory off of the heap. You know. So Linux, Unix, Mac, you have Valgrind. On the PC side of the equation, there's WinLeak. Valgrind, I don't have experience with WinLeak directly, and haven't heard a whole lot of clients mention it. Valgrind, yeah, I've played around with that and have heard that mentioned. One of the things to keep in mind about Valgrind is it has a very heavy, what's referred to as a probe effect. The probe effect is the way that the tool affects the system being tested. It consumes a lot of memory, which is kind of a problem when you're looking for memory leaks, huh? Right? I mean, it's kind of interferes with what you're trying to test. So, I guess you could say, what do you want for nothing? Right? It's free, and it is open source, and it's very tunable. Expect to spend some time learning how to master it. If you just start using it and you don't spend time understanding what it's doing, it can be a little confusing. You'll get results that at first seem to be telling you one thing, but then when you dig into it more closely, they're telling you something else. So make sure, again, like the performance testing tools, that you know what you're doing with this thing. Okay, so a lot of you are in the land of Agile. Yeah. Feature verification testing of one kind or another. Acceptance test-driven development, behavior-driven development. I refer to those as functional verification tests or feature verification tests. And the reason I'm using the word verify here is the tests are all going to be created from the user stories or the acceptance criteria for the user stories, right? So they're verifying that the specified requirements have been met. And it's important to keep in mind that, verification is great. Yeah, we need to verify things. But there's also validation, which is demonstrating that it actually solves a real problem for a real person who really matters, right? And verification by itself does not equal validation. They are partially overlapping sets. Okay? So the reason I mention this is that some of our clients kind of over-rely on this stuff. Oh, what could possibly go wrong? Well, we have, one of my favorites, I'll hear something like, well, we've got 5,000 fitness tests doing acceptance test-driven development testing for us. So we can change anything we want, and we don't have to worry about anything being broken by that. I see. You have discovered the magic bullet, the test that can kill 100% of the bugs. I hear that. I hear that about unit tests too. So there's a line in one of Kent Beck's books, I think it's Extreme Programming Explained, where he says something about, you've got this complete set of unit tests created via test-driven development, which means you can refactor your code anytime and you don't have to worry about breaking it. Really? Really? A unit test that can find 100% of the regression bugs. A unit test that can find 100% of any bugs. I don't think so. All right. Typical defect detection effectiveness of a unit test is 25%. And typical defect detection effectiveness of a black box set of tests, a very complete black box set of tests, is about 85%. Okay. So, this is great. Sure, I'm not saying don't bother with unit testing, don't bother with doing this feature verification testing. Absolutely, do it. Create the tests and ideally, put them in your continuous integration frameworks, which we'll all talk about in a minute. Put them in there. Yeah, that's good. But don't fool yourself about what you're getting out of this. You do not have a bulletproof shield against regression bugs. You've got a filter that will remove a significant portion of the regression bugs, but not all of them, and it doesn't demonstrate that the system actually solves anybody's problems. Not completely. Okay, now when I created these slides, up until that point, I had never encountered a client that had successfully implemented Agile without also implementing continuous integration. And 2 weeks ago, I did. They seem to be fairly successful, but no, they don't have complete continuous integration frameworks because they're doing something that I hadn't run into before, which is Agile for mainframe software. So they're like, where do we find a COBOL version of Jenkins or Hudson? I said, well, no, you're not going to find that, but it's open source, so you can port it over to your environment. But that's a pretty heavy lift. Most of our clients, they're working in some sort of environment where there's a version of Jenkins or Hudson available for a continuous integration purpose, and they've snapped in various kinds of tests into that framework. And definitely helpful from a testing point of view to get you reliable, testable builds. Now, I have seen some problems with this. You do have to be a little careful because we have one client that said, oh yeah, we've got this continuous integration framework. Every morning it produces a build, and then one of the people in the test team, they're like 10 testers, one of the people in the test team just copies it into the test environment. Like, they just do it? And so, yeah, he just comes in every morning and checks to see if the build worked, and around 10 or 10:30, he copies it into the test environment. I'm like, you mean, okay, so all the other testers are testing, and he does that? Oh, yeah. And I asked the other testers, you ever notice like around 10:30 in the morning you're running a test and all of a sudden it goes bloop and you have to start over again? They're like, oh, yeah, that happens every morning around 10:30. All right, so, it's okay to shoot yourself in the foot, but don't reload. Okay, I mean, think about it. People having to start over. I mean, they were losing probably about 8 or 9 person hours of effort every morning at 10 o'clock, 10:30 because of that. So, be smart. Okay, so unit testing, here we're talking about CPP unit, JUnit, the so-called XUnit family of tools. Again, assuming that you're in an environment where you're using a language where these tools are available, you're in good shape. Now, the good news is that these tools are available for a whole lot of programming languages. For my mainframe clients, sadly, not COBOL. They're like, there's no COBOL. So, well, you can try porting it over. Now, there are code coverage analysis tools, which ideally should be used with these tools when you're doing unit testing. I say should be. They often are. I see a lot of developers out there using code coverage tools now, which is great, except that they usually don't understand what exactly the tools are telling them. So, I'll ask developers when I'm doing an assessment, oh, okay, so you're doing code coverage. Yeah. What are you shooting for? 100%? That'd be 100% statement or branch coverage? Oh, what's the difference? Right. Are you getting MCDC coverage? Oh, no, I don't listen to AC/DC. I listen to other music. They don't know. They don't know what these tools are telling them, right? So this is an opportunity for you as a tester to learn more about programming testing, program-based testing, white box testing, what these tools are actually telling you, and help the developers get more value out of unit testing by achieving better coverage. Now, something else that we see used and often successfully is static code analysis tools. Sonar and Splint seem to be the most typical open source options that we're running into. You have to be careful that you use the right command line options with them. There are also complexity analysis tools, static complexity analysis tools. So for example, in the Linux world, there's a tool called PM McCabe that will give you McCabe cyclomatic complexity metrics for code. Now be careful with this PM McCabe tool if you decide to use it, because their interpretation of McCabe cyclomatic complexity is a little bit different than what McCabe wrote in his original paper on it. Okay, so do read the documentation, because you'll need to look at that. So these are useful. They certainly can find many different kinds of problems related to unmaintainable code, bad commenting, bad naming of variables, and so forth. But unfortunately, what we see with some of our clients is a attempt to substitute proper code reviews with these static analysis tools. Okay? The thing to keep in mind is that the tool can tell you whether or not you wrote the code correctly, but it can't tell you whether or not you wrote the correct code. You all see the difference that I'm making there? It has no way of understanding the problem you're trying to solve, and therefore it's got no way of understanding whether the code it's looking at is actually solving that problem. A human being in a code review can. And then there are test design tools, and if you're going to do pairwise tests, how many of you know when I say pairwise testing what I'm talking about? Combinatorial testing, orthogonal arrays, classification trees. Okay, if you're dealing with a situation where you have all sorts of different configuration options that are supposed to be independent, and you looked at it and go, wow, if I've calculated all the total different combinations, I've got 10 bazillion, right? If that's a problem that you have, you need to look at some of these pairwise tools, okay? Go to pairwise.org, take a look at some of the options out there. My personal favorite is ACTS, that ACTS. It's a free tool. There's also PICT, P-I-C-T. So, those are good options, and they're fairly easy to learn and very powerful tools. We hear a lot of people talking about model-based testing, automated model-based testing, but we're not seeing a lot of it. I helped a client build a model-based testing framework once for a handheld medical device. And it worked, but it was a very specialized situation because their requirements were written in a standardized way using a formal language in a machine-readable format, which made it very easy to use the requirements as an input into the test design tool and automatically design tests from them, and then turn that over to the automation piece, which would automatically run them. So, I guess I can say that I have seen not a unicorn, because those don't exist, but the black swan, was just something very, very, very rare, right? And then scripting tools. There are a lot of really good scripting tools out there. In fact, there's actually too many. There's too many scripting tools. And you might say, how can there be too many? What's too many? Right? I go into my closet that I share with my wife. I'm like, look at all those shoes. Isn't that too many? And she says, don't get me started, because I'll look at your gun collection. So then I shut up, right? So, but seriously, there are too many of these scripting tools. And the reason I say there are too many is that what we see happening is that companies don't standardize. And so you'll get one group using one scripting language, another group using another group using another, and it's the Tower of Babel. You know that story? Tower of Babel? Yeah, everybody's going to build a tower up to heaven because they want to ask God some questions. God decides he doesn't like that idea, so he makes them all speak different languages, right? Tower of Babel. Oh, I've seen that with a lot of clients, and that creates a lot of waste. But, so standardize within an organization. This is the scripting language we're going to use to do this kind of scripting, and train everybody in how to do it, if you possibly can. Now, you might say, well, I'm not a programmer. Don't worry, this isn't hard to learn. You can teach yourself these scripting languages, and in fact, it's a good gateway to learning programming. So if you don't know how to program and you're a tester, that's not a good thing. You should know how to program. Start by teaching yourself these scripting languages. And it's amazing the kind of things that you can build with these if you are careful with the architecture. Okay, so we'll wind this up and we'll take some questions. So I've shown you 10 different areas where you can use open source tools for testing by testers, testing by developers, or ideally both. If you are a manager, again, I just want to reinforce something I said at the beginning. You know, free is not free. It's free to download, but it's not free in the sense that your time is not free, right? So don't, as a manager, be careful about that. Don't just assume, oh, free means we can go off and do this, because there's a direct cost of the people's time, and there's also opportunity costs. People could be doing other things that might be more valuable than playing around with an open source tool. Okay, so keep that in mind. Now, so those caveats in place, I would say that we have seen a lot of clients that are having a lot of success with open source tools. Less than there should be, though. I still see a lot of clients that are sticking with the commercial tools and like, oh, no, we're not going to look at that open source stuff. I'm like, why? Well, I don't know, we always use the tools. Well, that must make your tool vendors' salespeople very happy. I don't know if that should be making you very happy, right? So if you're not looking at open source because of something, figure out what that something is, that obstacle, and get it out of the way. Sometimes the obstacle is support options, okay? We're not very technical and we don't know how to modify the tool ourselves. That might or might not be a surmountable obstacle, though. But don't just assume we're not technical, therefore we can't use the open source tools. Because a lot of them, the quality of the open source tools is as good, or in some cases better, than their commercial competitors. So, keep them in mind. There's a lot of cool stuff out there, and it's free. So, I have time for questions? Yes? Yes. No? Okay. Questions? Anyone? You're going to get your exercise because they're all, there's 3 hands up in the back. That pesky on switch. Obviously not an open source microphone.
Irina, PayPal Deutschland. So you said about some statistics, unit test effectiveness and functional test effectiveness. For unit test is 25% and for functional test 85%. Can you give us some background how you measured that?
Okay, so the unit test effectiveness, that comes from Capers-Jones studies. I think that the most recent book that I saw that figure in is The Economics of Software Quality. Capers-Jones, published in 2011 or something like that. The 85% figure is actually not only functional verification test. I'm not saying functional verification testing by itself is 85%. What I'm saying is a independent test team that is doing system testing, which in an agile environment would include functional verification testing. When we have measured those teams, they typically find 85% of the bugs. So if they're delivered software that has 100 bugs in it, they will find 85, and 15 will be subsequently discovered by the customers. Does that answer the question? Yeah? Okay. So those are my own studies that I've done. All right, who's next?
Hi, Rex.
Hey.
My name is Andrew, and my question is about test case management tools, which are better for free.
So, test case management tools that are free would typically fall under the category of test management tools, open source test management tools. And that's not in my presentation because I wanted to include in my presentation categories of tools that I had seen people use open source examples of successfully. Unfortunately, none of our clients have yet reported to me what I would consider to be a successful use of open source test management tools. Now that said, there are a lot of open source test management tools out there available. And I certainly can't pretend to have spoken to every test manager in the entire world. So I would encourage you to go off and take a look at those and do some research on your own, because I wouldn't be surprised if there are good ones out there. A test management tool is not a terribly complicated thing from an architectural point of view. It's not that hard to design a good one. So, take a look, see what you find. And let me know, okay? If you use one and you have success with it, send me an email and say, hey, I used this one and it worked out really well and here's what I'm doing with it, because I'm always interested in gathering up these success reports so that I can pass them on to other people. All right, another question?
Rex?
Yes.
So we got a pretty impressive slide regarding verification free tools. Now what about validation? A bit more tricky. I see only 2 tools with communication and common sense. Any other that you have observed?
Yeah, most of the time when you're talking about validation, to the extent that's not addressed by the verification piece, which it partially is, but not all of it. What you're talking about is some sort of manual testing, right? Which would, in an agile world, what we're talking about here is, what Crispin and Gregory would refer to as the 3 amigos, right? The tester, the developer, and the business stakeholder / product owner communicating about what it would mean to actually solve the problem. Now, in Agile, part of this is supposed to be happening during iteration planning, right? When you're going through the user stories and defining the acceptance criteria for them and so forth, and doing acceptance test-driven development and so on, that's a collaborative process that is refining the user story, and that's part of the validation right there, right? That's the making sure we're going to build the right thing. But then there has to be another piece after the software's built where you have the testers doing things like checklist-based testing and Elizabeth Hendrickson's bug hunting technique and the exploratory testing techniques that Whitaker and Bach and so forth talk about. And then, of course, some form of acceptance test done by the user, him or herself, or the business stakeholder that represents the user. Right, and yeah, excuse me, you can't really automate it, right? Because anything that you would do that was automated is inherently verification, right? Because verification is checking that specified requirements are met. So basically an automated test case of any form is a specified requirement. So anytime you're doing automated testing, you're necessarily doing verification rather than validation primarily. So, good question.
Hi, my name is German. Rex, could you tell us, please, what is better, to download open source tools and pay money to developers for some special features, or should we talk to our customers, estimate time, and develop our own tools exactly for our projects, our teams?
Now, I can't address your specific situation because it's possible that your case could be an exception. But in pretty much every case that I have seen, it's almost always better to start with open source and customize than to start from scratch. Even if you are going to be doing a lot of building of the tool, there's some tremendous open source stuff out there that can be used as the building blocks of that. So for example, the programming language TCL or scripting language, TCL scripting language, sometimes called TCL, is a fantastic platform that I've used to build automated tests on a number of occasions. It can be downloaded and used as a basis for that. There's all sorts of really good building blocks out there that are available. So I would say, assume that you are going to be able to use open source stuff and either customize it to meet your specific needs or download the basic building blocks and build from it. But certainly, that's an assumption. You want to check that assumption before you start the project. You want to have a plan. Okay? All right.
Okay, hi Rex, my name is Andrei, and my question is about tools as a group of record play tools. So the user just clicking, this tool records his actions and it's replayed. Have you experience of successful using of such tools?
No. Record playback sort of tools, basically what's going to happen is that you're going to have these exceptionally brittle, unmaintainable scripts that are produced by that. And you get timing issues, there's all sorts of problems. So there's limited use of those record playback tools for purposes of capturing non-scripted testing, like exploratory testing or bug hunts or something like that. You capture it, and then if you see a bug, you can attach that script so that the developer might be able to recreate it. But even in that case, it's, might or might not work. I would say you're much better off using some sort of tool like Snagit or something to do a video capture so that you can send a video of what happened to the developer so that they can see it. But yeah, capture playback as a sustainable approach for doing graphical user interface test automation is, I'm not aware of anyone doing that successfully.